So we are talking about measures of position and outliers. Remember, you have your formula sheet that will be given to you on the quiz as well. So you don't necessarily have to memorize formulas, you just need to know how to use the different things that we are talking about. Big thing that we are going to start talking about today are what are called z-scores. And a z-score essentially allows us to compare different sets of data. You know, if I gave a test in my statistics class and I gave a test in my calculus class, how could I compare those tests to one another? You know, or if I want to compare your score, I want to compare Elizabeth's score on her calculus test to her score on her statistics test. It's not as simple as just saying, well, she got a higher percent on the statistics one, she did better, because it's all relative to what the average was for each class. So we need to be able to compare these different sets of data, and that's where what's called a z-score comes in. So a z-score basically is kind of what we were talking about with the empirical rule on some of those. We're finding how far you are from the mean in terms of sample, or in terms of standard deviations. I have two formulas here. I have a population and a sample. The only difference is the variable. We know it in a population we use mu and sigma. In a sample it's x bar and s. But essentially what you need to know is it's your score minus the average divided by standard deviation. A z-score doesn't have any units on it. It's not a percent or anything like that. It's a unitless measure. Mean is 0, standard deviation 1. Really, though, the important part there is just knowing how to calculate it. So we are going to just start with an example and compare two different things. The mean height of males 20 years or older is 69.1 inches with a standard deviation of 2.8 inches. The mean height of females 20 years or older is 63.7 inches with a standard deviation of 2.7. Which of these people is relatively taller? Ken, who has a height of 83 inches, or Candace, who has a height of 76? So I'm not asking which of these two people is taller. I'm asking which of them is taller relative to the other people in the group. Okay, so is he taller compared to the other males, or is she taller compared to the other females? So what we will do is calculate the z-score for each person. So our z is your x, that's your value. How tall is Kevin? Minus the mean. What is the mean height for the males? Divided by standard deviation. Standard deviation for the males was 2.8. And so, typically z-scores we round to 2 decimal places. 4.96 is his z-score. So Candace her height is 76. What is the mean height for the females? Over the standard deviation for the females. And so she gets AZ score of 4.56. Okay, what this says is her score is a little over 4.5 standard deviations above the mean. His score is almost 5 standard deviations above the mean. So who is taller? Kevin. A bigger Z means further away from the mean, so that's more abnormal. Okay, so he would be taller because he has a bigger Z value. His height is further away from the average height for the mean.
It's not fair to say like male and females compare, so that's why we do that.
Right. So he is relatively taller. What would a negative Z-score mean?
There was less.
Their score was so much less than the mean. Oh, forgot to put my negative too. Okay. Any questions about that? The other thing that we're going to be talking about are percentiles. For a percentile, we use a capital P and then a subscript. So like P with a subscript of 10 would refer to the 10th percentile. It's telling you what percent of the data is less than or equal to that value. So like the first percentile means 1% of the scores are less than or equal to that, so 99% of the scores would be higher than that value. Now, if I said the 98th percentile, 98% of the scores were less than or equal to that, so 2% of the scores would be above. So really right now we're just going to be focusing on making sure we can interpret this and know what it means. So I just want to give us an example and make sure we can write a sentence about what that is telling us. So the graduate record examination, GRE, if you're going to go to grad school, you get to take this test, is a test required for admission to many U.S. graduate schools. The University of Pittsburgh Graduate School of Public Health requires a GRE score no less than the 70th percentile for admission into their human genetics MPH or MS program. Interpret this admissions requirement. So what does it mean when it says the 70th percentile?
It's like if you're at 70 or below, you can't.
Right.
Based
So-
on other people. Right.
Right. So it's not saying you have to get 70% of the questions right. It's saying they are going to compare your scores to everyone else. So the 70th percentile means that 70% of the scores are that or below. You have to be above that. So you have to have a score in the top 30%. Is essentially what this is saying. So the score must be high enough that 70% of the scores are below that data.
They use that with like babies when they're trying
Mm-hmm.
head is in
Yeah. Yeah, when I take my kids to the doctor, it tells me, you know, my oldest one and my youngest one are really short like me, so they're like 25th percentile for their height. And then my middle one is tall. Works out good. Okay, so the key thing about percentiles, it's not getting a percent correct, it's just comparing main percentiles we are going to be looking at are referred to as quartiles. What do you think quartiles represent? The fourths, yes. So, quartiles, be breaking it into fourths. So, really what you might want to write down, I don't know if I'd even write this, I would just say quartile 1 is the same as the 25th percentile. Quartile 2 is the same as the 50th percentile. We have a name for that already. What is the score in the middle? That's the median. Quartile 3 is the same as the 75th percentile. The fourth one would just be your highest data point because it would mean 100% of the data was below that. So we only use the 3 quartiles. So let's just look at a set of data and see if we could find our quartiles. A group of Brigham Young University, Idaho students collected data on the speed of vehicles traveling through a construction zone on a state highway, where the posted speed was 25 miles per hour. So here are 14 randomly selected vehicles.
I'm going 40.
Find and interpret the quartiles. Okay. Probably the easiest way to go about this.
Just split it in half, then split it in half again.
Yep. Quartile 2 is the same as the median, and we've talked about how to find the median. Since there are 14 scores, is one of my, or 14 speeds, will one of my speeds exactly be the median? No, what we would have to do, let's see, 1, 2, 3. So, my middle would be when you have 7 above and 7 below. So that would be in between 32 and 33. So how would I find my median? Yep, you would add them up. Divide by 2 and you get 32.5. Now essentially all we have to do for the first quartile, we know here's the middle. So what's the middle of the bottom half? 28. And you've got 3 on each side. So that's quartile 1. Quartile 3?
Just the middle of the
Middle of the upper half. So this means 25% of my scores were 28 or below. Keep saying scores, speeds. 50% of my speeds were 32.5 miles per hour or below. 75% of my speeds were 38 miles per hour or below. You can also tell if your data is skewed by looking at this. Sometimes I may just ask you for the quartiles and then I'll say, describe the shape of the distribution. You could certainly make a histogram, find that shape. Or we could look, how far is it between quartile 1 and quartile 2? What's the difference? How far is it between quartile 2 and quartile 3? Okay. There's not much difference. They're pretty close to the same, so that means our data is going to be fairly symmetric. If one of these was a lot smaller though, if this was like 15.5, that would mean there's a lot bigger distance between the second and third quartile. So we have a lot more spread over there. So that would mean our data would be skewed. Would mean we would have more higher data points. So that would mean it would be skewed.
What?
If we had a bigger difference.
Oh, okay.
There. So like, here's quartile 1, quartile 2, quartile 3. So it'd be like drawing it, here's the center, this is spread out further. So that's skewed to the keep hearing different things. Do we agree it's to the right?
Oh.
Okay. If there's a bigger spread between quartile 1 and quartile 2, that means there are more lower scores, so it'd be skewed to the left. All right. We'll do one more thing and then we're going to stop with this for today. Interquartile range is just the range of the middle 50% of data. So interquartile range, it's often called IQR. It's just quartile 3 minus quartile 1. Let's just, last example for today, I want the interquartile range of that speed example. So the interquartile range for that, quartile 3 was minus quartile 1, which was 28, and we get 10. So interpret, that means there is a 10 mile per hour difference. Between quartile 1 and quartile 3. Another way to think of it is basically 50% of our data fell within 10 miles per hour of one another. Okay, I am not done with this section. I have done enough that you could start the homework if you wanted. I will put it up here if you want to write this down. We are doing a quiz tomorrow.
No, I already did 9 through 11 on that.
Over sections 3.1 to 3.3. So that's last week's stuff.
Well, it makes sense, but I didn't know how to do it.
This assignment, I will finish this section. If we have time after the quiz, I'll finish it. Then, if not, I will finish it Wednesday. So it will actually be due on Thursday. So let's just say I gave you this data. Alright, I want X bar. How do you do that? And remember, if you need your formula sheet, you can pull it out and look at it because we are able to use formula sheets. How do I find X bar? That's the mean. So we add them up
The average.
and divide. Okay, find our average real quick. Can I? Yeah. Okay, loading it. Okay, you guys get that? Now on the quiz, I would recommend showing me a little work just in case you make a silly mistake. So you might show me like 76 divided by 8, just so I know how you got your answer. B, what if I said find capital M? What does capital M represent? Median. So if I had to write these in order from small to large, so that would be 3, 5, 7, 8, 12, 13, 13, 15. Okay, how am I going to find the middle?
We just count.
Okay, the middle on this one is going to be between 8 and 12, so I would have to add up 8 plus 12 divided by 2, and we get 10. How do you find the mode? Which one occurs the most on this? 13, that's my mode. What if I said the range?
Take the largest one
So 15 minus 3 is 12. So you guys could find all that stuff? Okay, let's talk standard deviation. I've shown you how to do that on your calculator and by hand. I told you that if I ask you to do it by hand, it will probably just be one problem, and it'll be a small data set. So this would be a small one we could do by hand. Okay, so if we made a table, we did our x minus x bar, and our x minus x bar squared.
Does it matter what order they're in?
No. Okay. For the sake of time, I don't know if I'm going to work all this out, but we do each of these minus your mean, right? What was my mean?
9.5.
Okay, so you do 8 minus 9.5, square your answer. Okay, so I'm kind of breezing through this for the sake of time. Do you guys know how I'm getting these? Then how do I find my standard deviation from that? You've got your formula sheet. Add those up.
And the last column.
Yes. Keep in mind, if I say you have to do it by hand, you have to do it by hand. You could also do it on the calculator to check yourself, but you are going to have to do it by hand.
I got 132.5.
132.5.
I got 2.
What'd you guys get?
Love this.
I got 132.
I got 132, but only 2 back.
I think I might have miskeyed one. Then you divide by, let's assume this was the sample. So you divide by n minus 1. So I had 8 points, so you would divide by 7. Again, I would show me that work, especially if I'm telling you to do it by hand. I have to know that you actually did it by hand, so I have to see your work. And I get 4.3425. If I ask for the variance, what do you do? Variance is just s squared, just your standard deviation squared. So I just take that number and square it, and I get 18.8573. Okay.
Did you just take your little ones?
Yes, I did.
Did you get like more?
This was that first section. Are we okay with that? The second section was when we did all the other things. So let's say I give you something with a mean of 35, a standard deviation of 3.8. And I asked you what percent of your data fell between, let's say 27.4 and 42.6 based on the empirical.
So you have to figure out how far away those are.
Yes, we need to figure out our number of standard deviations first. So you would have to do 35 minus your 27.4, and 35 plus, sorry, and 42.6 minus your 35.
Minus
Yeah, you're just trying to find distance from. And both times I get 7.6. How do I figure out how many standard deviations that is? Divided by 3.8, and what do we get? 2. For both of them. So 2 standard deviations above and below, by the empirical rule, what percent should that be? 95%. You should be able to do those weighted averages. So like, if I said we had the bridge mix example. You know, you're buying 3 pounds of something that costs $1.75 and 2.5 pounds of something that costs $4.25. So being able to add those up, divide by your total. You should be able to do standard deviation on your calculator. You guys know how to do that. You enter it into your L1 and yep. You go to your stat edit, enter your L1, and then you can go into the edit or the calculate one variable statistics, get your mean, median, standard deviation, all of that. If you're comparing standard deviations, a higher standard deviation means what? More spread out. So if I'm asking, you know, which group has more variability, the higher the standard deviation, the more spread out it is. Talking about central tendency, we talked about mean and median. How do you know which one is better?
The mean is, because the median's just.
It depends on the data. Though. Remember we said if it's nice symmetric data, the mean is better. If your data is skewed, which one's better? Well,
it's your mean if it's skewed, but if it's not, then it's your median.
Right. So the direction of the skew will impact if your mean is above or below your median. But just in general, if our data is skewed, the mean is going to change, so the median is a better measure. Whereas if you have symmetric data, the mean is a good option. Trying to think of anything else. Okay. Anything else? Trying to think. Do like a GPA. Okay. You got an A in 2 classes, a B in 3 classes, a C in, how many classes do you guys have today?
8, 7.
Yeah. So let's say we did this. An A is worth 4 points, a B is worth 3, and a C is worth 2. So you would take your 4 times 2 plus your 3 times 3 plus your 2 times 2 and divide by how many classes were we taking? 7. So you get a GPA of 3.0. Those are the 3 problems that you did on the wrong page. So when you do those,
Alright, makes sense.
yeah.
Although I don't remember.
Okay, come in if you have any other questions. Okay.